This lesson is let B, B1, B2, let C, C1, C2 be the basis of R2. Find the change of coordinate matrix from B to C, and the notation of B to C is this: B, left arrow, and then C is on the left side. So B to C, so B to C. And then C to B, the notation C, left arrow, B. Okay, so B to C is written as this. C to B is written as this. So here I have B1, B2, C1, C2. These are the four vectors. And first, we need to find B to C. So C is on the left side, B is on the right. Just like this, C on the left, B is on the right, because we want B to C. So C over here and then B. So put these together as one matrix. So here's C1, C2, B1, B2. Now do row operations or row reducing so that it comes down to here. So here this is a 1, so I leave it alone. This is -5. I want it to be a 0. So opposite of -5 will be +5. So 5 times row 1 plus row 2. So 5 times 1 is 5. Subtract 5 gives me 0. 5 times -2 is -10 plus 2, -8. 5 times 7 is 35 plus 5 gives me this 40. 5 times -3 will be -15 plus -1 gives me -16. Next, I want this -8 to be a +1. So multiply the reciprocal, which is 1/8. But there's a negative here, so I need another negative, so become +1. 2. Okay, so -1/8 times -8 gives me +1. -1/8 times 40 gives me -5. -1/8 times -16 gives me this +2. Next, we need this right here to be a 0, the -2 to become a 0. So opposite should be +2. So 2 times row 2 and then plus row 1. So 2 times 1 will be 2. Subtract 2 gives me this 0. 2 times -5 is -10 plus 7 gives me -3. 2 times 2 gives me 4. Subtract 3 gives me +1. Now this is completely done because I have 1, 0, 0, 1. Once I have 1, 0, 0, 1, it is completely done. And then this over here will be our answer from B to C. And that is the answer that we are looking for. Okay, so find the change of coordinate matrix from B to C. This is our B to C. So this right here is our answer to B to C. Next, we need to find the inverse of this. The inverse of this. So find the determinant of 2 by 2. So A times D, which is here, minus B times C, which is here. And then we just simplify, so that gives me -6. This right here gives me -5, but have another negative become +5. So -6 plus 5 gives me -1. Okay, and I'm going to move this up so you can see. So now we want the answer of C to B, which is technically the inverse of B to C. Okay, so if you remember the determinant formula for 2 by 2, so I wrote it here. The inverse for 2 by 2. Again, this formula is only for 2 by 2. So the formula is 1 over the determinant, dA switch, -B and -C. So this is my A, this is my D. So switch these two numbers. So 2 here and 3 here. The 1 and the 5, put another negative in. So 1 becomes a -1. There's another negative, so negative and negative become +5. Okay. And this is right here is our determinant, -1. So 1 divided by Negative 1 is still negative 1. Multiply by 2 gives me negative 2. Multiply the negative 1 gives me positive 1. Multiply the negative 1 gives me negative 5. Multiply the negative 1 gives me this positive 3. So this is our answer for C2B, which is also the inverse of B to C. Okay, so be very careful. One more time, move this down. We are looking for B to C. This is our answer, B to C. Now we also want that, so we also going to find B to C. So B to C, okay? So B to C, I'm sorry. The answer for B to C will be this. We are looking also for C to B, which is this right here. And this answer is technically the inverse of B to C. One more time. This is the answer from B to C. This is the answer for C to B, which is also the inverse of B to C. Okay, so one more time. This is the answer for B to C, so B to C. This is the answer for C to B, which is also the same as the inverse of B to C. Okay, so here I rewrote the formula for inverse 2 by 2. Again, this is only for 2 by 2. You cannot use this formula for 3 by 3, 4 by 4, and so on. And be very careful. If you remember, determinant A cannot equal 0. If it does equal 0, you have no solution and no inverse. Okay. Now this is another way to find the inverse of any n by n matrix. 2 by 2, 3 by 3, 4 by 4, and so on. You will write the matrix that you're going to find the inverse, and on the right side you will write the identity matrix. Your objective is to move this identity to the left, which I have here, and then move all of these to the right, which I have here. Once it is completely moved to the right, and that will become the inverse. Okay, so this is another method to find the inverse of any n by n matrix. So on the left side is the matrix that you're going to want to find the inverse. This is the identity matrix. Your objective is to move this identity to the left, which I have here, and then move this to the right, which I have here, which will become the inverse. Okay, so this right here needs to be a -1. So reciprocal of 3, 1/3. I want a +1, but there's a negative here. I need to put another negative. Okay, so -1/3 times -3 gives me this 1. -1/3 times 1 is just -1/3. -1/3 times this 1 will give me this -1/3. And then -1/3 times 0 is just this 0. Next, I need this 5 right here, this -5 to become a 0. So opposite of -5 would be +5. So 5 times R1 plus R2. So 5 times 1 is 5, subtract 5 is this 0. 5 times -1/3, which I have here, plus 2, which I have here, cross multiply, gives me -5 and 6 on top. Under multiply gives me 3. And then add, subtract the top. 6 subtract 5 gives me 1/3, which is this 1/3 here. So this 1/3 is this 1/3. Next, 5 times -1/3 is -5/3 plus 0, which is this -5/3. 5 times 0 is just 0 plus 1 is this 1. Okay. Next, I want this 1/3 to be a +1 here. So multiply 3, since the reciprocal of 1/3 is 3. Okay, because I need that +1. So 3 times 1/3 gives me this 1. 3 times negative 5 over 3 will give me this negative 5 because the 3 will cancel. I just have left is negative 5. And then 3 times this 1 will give me this 3. Okay? Next, I need this right here to be a 0. So opposite of negative 1/3 will be positive 1/3. So 1/3 times row 2 plus row 1. So 1/3 times 1 is positive 1/3. Subtract 1/3 gives me this 0. 1/3 times negative 5, which I have here. Okay, and then plus this negative 1/3, which is here. So 1/3 times negative 5, which is here, plus 1/3 plus negative 1/3, which is here. Now in this situation, the denominator already the same. We don't need to cross multiply here. As you can see here, the denominator are not the same. We cross multiply. Here, the denominator already the same. So we just add the top only. Add or subtract the top only. So negative 5 plus negative 1 gives me negative 6. Divide gives me negative 2. So that's where the negative 2 come from. And then 1/3 times 3, which is 1. 1 plus 0, which is this 1. So as you can see, I move the identity from right to left. That's what I have here. And then this from left to right, which I have here. So now this becomes our inverse. So and you can see this is the same as this up here. Okay, this is the same as this up here. Again, this right here, what I did is only for 2 by 2. You cannot use this for 3 by 3. However, if you have a 3 by 3, 4 by 4, 5 by 5, and so on, use this method. Okay, so this method will find any, okay, this method to find the inverse for any n by n matrix. So 2 by 2, 3 by 3, 4 by 4, and so on. And this will work to find the matrix, the inverse matrix for any n by n matrix. Okay, so one more time. We are looking for B to C, which is this one. Next, we are looking for C to B, which is this one. However, this is the same as this, and it is the inverse of B to C. Okay,